Hey guys, today we're doing Chapter 2, Section 3, which is on the line of best fit. So first thing, we've got some vocabulary here. We've got observed values. That's the data that's collected from experiments or surveys. So observed values are actual real-life data points. Okay, predicted values are data points predicted by a mathematical model. So in other words, if you come up with an equation for a situation, you want to predict values using that equation. Those are called predicted values. Okay, your error is your observed values minus your predicted values. So basically, if you take an observed value, so a real data point, minus a data point that you plugged into an equation, which is a predicted value, that gives you the error of your model. Okay, let's consider the table below. Let the predicted equation be y equals negative x plus 11.8. So in other words, I'm modeling these real-life data points with this equation. Okay, so these are my actual x values, these are my actual y values, so this would be considered my observed y. If I want to find my predicted y values, what I'm going to do is I'm going to plug these x values into this mathematical model here. So if I plug in a 2, I have negative 2 plus 11.8, that gives me 9.8. So that would be my predicted y value for x equals 2. Now I'm going to do the same thing for all these other x values. So if I plug in a 4, I would get 7.8. If I plug in a 6, I would get 5.8. If I plug in an 8, I would get 3.8. And if I plug in a 10, I would get 1.8. Now I want to come up with my error. And remember that my error is my observed minus my predicted values. So I'm going to take my observed value minus my predicted value, and that's going to give me my error. So in this case, I had 10 minus 9.8 gives me 0.2. Okay, in this one I have 7 minus 7.8 gives me negative 0.8. 6 minus 5.8 gives me 0.2. 5 minus 3.8 gives me 1.2. And 1 minus 1.8 gives me negative 0.8. Now I want to come up with my error squared, so I'm just going to square each of the numbers in this column here. So 0.2 squared is 0.04. This one's going to be 0.64, 0.04, 1.44, and 0.64. Okay, so what is the sum of the squares of the errors? To find that, I'm just going to take this whole column here, I'm going to add them all up, and when I add those up, I get 2.8. So why the heck did I just do all that? Well, I did that because I want to determine how good my line of best fit is. So in other words, this is my line here, this is my mathematical model, and I'm trying to determine whether it's actually a good model or not. I know that our calculator gives us an R value, which is basically the equivalent of doing this. They are different processes because our calculator is a little bit smarter, but this is kind of the same concept where we're trying to find our deviations from the mean, and then we're using that to determine whether this is a good model. So the line of best fit is found by minimizing the errors in the predictions. So the smaller your sum of your squares of your errors are, the better model that you have. Basically, if all of your data points fall on the line, then all of your errors are going to be 0. So the sum of all your errors is going to be 0. So the closer it is to the line, the smaller the sum of your squares of your errors is. This is called the method of least squares. So it's the process of finding the line of best fit. That's what we just did here. There is one point that is always on or very close to the line of best fit, and it's called the center of gravity. It's calculated by finding the mean of the observed x values and the mean of the observed y values. So, in other words, our center of gravity is our mean of our x's, comma, our mean of our y's, or x bar, comma, y bar. So let's calculate the center of gravity for our table above. Basically what I'm going to go through is I'm going to add all these x values together, and since there's 5 of them, I'm going to divide by 5, and when I do that, I get 6. Okay, then I'm going to do the same thing for my observed y values, so I'm going to add all these together and divide by 5, and when I do that, I get 5.8. So that means that this point, our center of gravity here, is going to be either on or really, really close to our line of best fit. There's one more thing we need to talk about, and that's these vocab words, interpolation and extrapolation. Okay, these are going to be really important later on. I'm definitely going to ask you to do stuff like this on the test. I'll say, hey, extrapolate some data values, and you need to know what I'm talking about. Okay, so interpolation is when you make a prediction about data within the given information. So for our table above, interpolation would be making a prediction within x between 2 and 10. So basically, when you're predicting data that's within the given range of the given data, that is called interpolation. So you're making some sort of prediction, but it's within the same range that you are already given. Extrapolation is making a prediction about data outside of the given information. For our table above, extrapolation would be making a prediction about the data outside of the range between 2 and 10. Now, when you extrapolate data values, this depends on the assumption that a relationship will continue past or existed before known data. So extrapolation is not always a good thing, because we know that in history, we don't always have situations that continue the same trends over years and years. For example, let's say I was talking about DVDs versus VCRs, okay? Oh, DVDs versus VHS. Okay, if I had a model that was predicting the outcome of how many people were buying VHS tapes, and I wanted to extend it all the way out to the year 3000. Well, if I started back in, like, I don't know, the 1950s, the model I have would probably be increasing over the years. And it would not continue to increase in real life, so extrapolating a data value for the year 3000 wouldn't really make sense, because it would be a huge value, but we know that in real life people aren't buying VHS tapes anymore. Okay, so basically you want to really consider the situation when you're extrapolating values, and you want to make sure that the trend is actually still being followed. Okay, so you just need to be the judge about whether your mathematical model will hold true through a given date, okay? And that's everything for section 3.